Hopefully, if you've walked up to your sink at home and you've poured yourself a nice clear glass of water, you may wonder, wow, where do we get this clear liquid that's there? I mean, if you look at your local pond and it's kind of dirty, or if it's a stream that's behind your house, it never looks quite that good. Well, maybe you thought the pipe goes way out and you find some clean source. But really, in reality, is your city is doing some work on treating it. That's what you're going to explore today then when you get into the lab for this agricultural starter lab station. Water treatment. Your city takes quite some time to make sure that the water that shows up at your house is clear of particles and can have been cleared of any kinds of disease. And so they're going to do several steps along the way. One, they have to procure the water from a source like a river or a lake or maybe groundwater. The second step is they'll bring it into probably a central place and put that through some processes. Usually the first step is to take out anything that's large through a filtration, maybe a large pit of sand. Second, they'll also want to get some things that made it just through that coarse sort of filtering, maybe put some chemicals in there that cause the smallest particles to conglomerate together. It's called agglomeration and agglutination, I apologize. And that would bring them together and float to the bottom. They flock with the chemical, looks like little feathers. It's called flocculate. And it brings those out of the water system. Finally, they'll pass that now water that's probably got most of the particles out, any of the stuff that makes it look kind of like chocolate milk or something, and that's been pulled away. But they'll want to treat it one last time with something that could kill bacteria and small infectants. And they'll either treat it with sort of a chlorine or some kind of a substance that breaks down quite quickly as it's being delivered to your home. But then it will show up at your place free of particles, free of look. Most of the time free of color, if that and smell or taste, but sometimes that can also be gathered on the pipes on the way to your home. So we're going to get started here, and we're going to talk about how we start from some water source to get and try to make it as clean as possible, and you're going to try different kinds of methods to do that. To get started in the lab and to study what we want, first you're going to need a great source of water. Now, if your local stream or something is too far away, you can make some water yourself. Your teacher should be able to supply that. Maybe throw in a handful of dirt that would typically be in there. Make sure there's a little bit of clay so that stays in suspension, makes it a little bit more tricky to pull out. In this case, I put a little coffee in there so that you can continue to smell something that isn't just making it look cloudy, but actually has some kind of dissolved aspect to it that you're going to work to get out of that solution as well. So that's your water source. Next, you can take just a 2-liter bottle and you can use that as a filter. It's nice because this is far bigger than, say, your typical filter funnel that's there, but you can use a filter funnel as well. We're going to take that sample that we made of this sort of, we'll call it dirty water, and we're going to put those in 4 different containers. In each of those containers, we're going to do something different to see if we can't knock the substances that are in water out and make the cleanest water we can. Each of those is going to be a little different task. The first one that we put in is going to be unfiltered. It's just going to be allowed to settle by itself. Some of those particles, if you let water sit, you'll see that the substances come out. Next, we're going to take one of these samples and we're going to add a little bit of some pool clarifier. Now, in the city, they use something called alum. And so it's a compound of aluminum. I've taken the concentrated version and made it 4 parts per 100, 4 mils in a 100 mil sort of sample, and we can put that into that water and see what that does. It's supposed to create small molecules, actually bigger than molecules, sort of particles that kind of make a flocculant. It looks feathery, and that'll grab some of the materials and bring it down to the bottom. All right, our third attempt, we're going to take a look at just to see what happens if we let this sit. I poured these in here so we save some time. I put this in about an hour ago, and I let it sit a little longer than just the unfiltered one, which we're just going to stir and pour through our filter and see if that makes a difference. The very last one we're going to take a look at and use charcoal filter. Now, charcoal filter is activated charcoal is maybe what's heard. You can get it at pet stores for the filtering of water in a fish tank, and there's several other sources. Sometimes it comes as bigger. It looks like little pieces of sort of burnt wood. Then if that's the case, they're bigger pieces. Just grind them inside of a pestle, a mortar and pestle, to make them smaller particles. And so I've done that and put those in this little container here. So we'll put the sample into that and filter through that. Basically what you're going to do is, here I'll show you, as a setup part is you're going to take this, add some water to it, and stir that in there. So it's suspended. It looks really dark. And again, I've done this before to save a little time. You're going to make a little filter apparatus, and you're just going to pour this into that filter so it impregnates or gets stuck in the sides of the filter itself. That carbon in there is going to be good at taking out things that have some smell to them that may be dissolved. It has an attraction to molecules in the water, things that aren't just like particles like sand or even silt. But that give the color to water, give the smell and the taste to water that you'll have. So you're going to see if that, this is going to then be one of the methods is to pour through this particular filter, and I'll show you that process when we start gathering data. Now, each of these is like I said, here's our unfiltered, untreated. We're just going to stir that back up. We're going to pour that into the filter itself and allow it to drip through to the bottom into our 4 beakers that are here on each of these methods. And you're going to see which one seems to work the best for different kinds of reasons. We'll test those shortly. Finally, what you're going to do is going to have the chance to make your own filter. Well, in each of these you're going to make as well. And these are really simple to make. You just take a piece of paper toweling. You can fold it in half once. Notice this is just the size. And, get a nice square, cut it with a scissors or something. Fold it in half once, fold it in half a second time, and then pull one of these flaps out so that it makes sort of a funnel, okay? And inside of that funnel, you're going to take normal paper napkins, which usually fall apart. These are better with water. They don't fall apart. But these are a little bit more, the napkins that I'm suggesting to put inside of these paper towels are a little thicker, and they do a little better job. So we're going to use those 2 sets of filters as the standard, okay? And that's going to go inside of your other half of your cut 2-liter bottle. Now, you can, like I said, if you didn't make these, you may be given just a standard filter from your teacher, and you can put those inside as well. They will fit. They'll be a little bigger than that, so you got to make sure you kind of push them down in there to dump your water in. So either one will be great. This is the one I'm going to use because then that way you can go through more water if you need to. All right. Not that I'm gathering data, but I'm going to show you the process. Here's our just untreated and stirred, so there wasn't any time to allow this sediment to sink down. You're just going to pour that into your filter like this, and you're going to allow that to come through and drain into the bottom cup. Okay, now that may take a little bit of time because first it has to get wet, then it'll wet the sides, and then it'll work its way down to the bottom. I know that's going to take some time, so what we'll do is when I come back and we're going to go through the data gathering and analysis, I will have done that, and I'll take our little samples here that have already filtered through that process. What I will mention in this stage, though, is for one of your filtering, here's what it looked like when I poured that activated charcoal in first, and then I rinsed it 2 or 3 times to get anything that's loose to filter through and be out of the way. Then what's left impregnated on the sides is that activated charcoal. So one of the tests you're going to put, this is done after this has come through, and you can see it's taking its time. I'll put some more in there so that we get more liquid out. But one of those tests, you're going to use this filter that has the activated charcoal in it, okay? So when we come back, I'll have those ready for us, and then we'll start our analysis. So we've given the water that we've just filtered some time to make it all the way through. Some of them asked, for instance, this is just the water as it was. You can look inside, and again, it looks sort of like chocolate milk. But as I poured it straight into a filter after stirring it, I resuspended everything and put it through a filter, here's what that ends up looking like just through the filter once. The next one, here I added the pool clarifier, okay, which forms a light set of molecules that crystallize out and make sort of feathery looking thing, and they settle down. As a matter of fact, if I pull this up, if you're looking from the front camera, you can see if I shake that just a little bit, there's sort of a, like a light clayey look. It's almost like got waves in it. And I'll set it down so you can look from above. There's sort of a white filmy look at the bottom that formed a cloud, and then those slowly fell to the bottom and brought particles with them. And you can see after it's been filtered, that did a really good job. Here, it's much lighter than this first one. Next, I actually put the solution into, or this milky kind of solution in about an hour ago. In the lab, it just says for about half an hour. Let it sit there so that it slowly sank to the bottom. With time, you can see it's a little clearer than what we started with when it was when I disturbed it, stirred it. So some of this would settle out on its own, but it's taking its time. It certainly didn't come to the bottom as fast as when we put the alum in there, or the clarifier. And when we filtered that, you can still see that there's some, material that's on the bottom there. So some materials made it through the filter. Finally, we poured this into the filter that had the charcoal bits in it. Okay, so impregnated the filter paper with activated charcoal. And when we filtered that out, we've got this look. Now, I also rinsed this a couple times to make sure it's not just the carbon from the activated carbon making through. So it looks a little clearer probably than that, which was just raw that came through, but they're very similar. Okay, so that was our starting process to get the data. Now we're going to test that. Each of these, I want to see what's made it through, and I'm going to leave sort of a systematic approach to this. I'm going to use the conductivity sensor first to see if there's still anything that could have dissolved and dissociated, like ionic salt, that made it through. And we'll see if that made it through those filters. Next, we'll check the pH, okay? And finally, we'll take a look at how cloudy that is. This is called the turbidity sensor. Now, the very first, or the conductivity sensor, is good to go right at the start. You do not need to calibrate this. It's been calibrated from the factory, and so we're going to start that one, and you're going to see that when I put these in each of the solutions, and I'll write down my numbers as well as we go, that this is going to give us a feeling for how much salt is in there. I'm going to tip it back a little because we didn't get a lot. Notice with 20 mils, it's just enough to get the tip of these sensors wet. If I look down in the bottom, I can see that there is a reading here. But I'm going to hit the start button so you can see it as big numbers. These are called the live reading at the bottom of the software. But if I hit this, you're going to see, okay, here's run 1 of the first substance. And all I'm looking at is this 1,045, 1,048, 1,050 kind of number. Okay, so that's still got a lot of salt in it. I'm going to write those numbers down in my table. Okay, under the conductivity table. And this one was just filtered, 1,050. It went a little higher, but we'll keep that as a number. Next, I'm going to go ahead and rinse this off in between runs so I don't take from one and put it in the other. And we're going to put it into the little beaker that had the clarifier in it. All right, I can see the numbers in the bottom. As a matter of fact, it's got even a little bit more conductivity, maybe because the clarifier may have had some salt or something in it. So that's 1197. And that's agglutination, 1197. Awesome. Again, I'm going to rinse it off. Now we're going to put it into the beaker that was filtered after it had settled, just through sedimentation, I believe. Is that right? Let me look at mine. Oh, this is through activated charcoal. So this was filtered through the paper with activated charcoal. All right. Oh, and I didn't hit stop, but I'm still writing these down, so that's fine. If anything, it's about the same, at a scale of 1,000. It's a little lower, not tons lower. So activated charcoal is 1,038. Okay. It's important to realize that a scale, out of 1,000, if you're down 10 or 12, that's not a lot. Last one is, this is the one that was, had the, let me make sure, sedimentation. We just allowed the sediment to settle. So we'll see if it matches that first one very well. Okay, and that is coming out at 1130. Again, very similar to some of these others. Oh, that's sedimentation, 1130. And I forgot what it was. And it didn't. Oh, I just wrote it in the wrong column. 1197. Okay. Oh, I'm going to leave this one off for now. Agglutination without filtration. I still have it. I guess I can check it. Let me do that. So this one is the agglutination without filtration. $11.09. Okay, I'll clean this up before we finish. But that is the conductivity sensor. That is measuring how much saltiness there is in that solution, ionic substances that have dissolved and have dissociated. Okay, there's natural salts that are in soil that may continue, like limestone, calcium carbonate, even sodium chloride, sodium sulfates, all can be in water that's local. So, excellent. Let me clean this up real quick, and we will go on to then the next test, 1109. Okay, now we're going to use the pH sensor. pH sensor, if there is something dissolved, okay, if it's ionic, for instance, it breaks into two ions, pluses and minuses, and that'll be detected by the conductivity sensor. Now, this is going to look at each of those ions, and if one of those ions is an acid, an H, or if it's missing and it's got hydroxide in OH, then we're going to be able to sense it with the pH sensor. If they are not acid, nor are they base, they'll have a pH of around 7. If it's more acidic, it's going to have higher numbers of pH. I'm going to rinse this off real quick to make sure we get a good start without adding more to our substances. Okay, I'll go ahead and stop just as a marker to remember. And the next one we're going to look at is this big number on the right. Here's the unfiltered, untreated, and just pour it into the filter sensor. I'm going to lean it forward to get it as wet as possible. If you have more liquid than this that comes through, that's great. But this looks fairly much like normal water. It's 6.9. It's a little bit acidic, but not much. So if it's just allowed to settle through sedimentation, oh, we just ran it through the filter. That's this first one, 6.72. Okay, it's changing a little bit, but that's okay. I'll rinse that off. Now I'll put it into the activated, I'm going to follow through the table here, activated charcoal, and then filtered. So I'll just follow that table. That'll make a little more sense if you're watching from above. Oh, interesting. It's a little higher, 6.95. That was filtered through activated charcoal. Okay, the next one is look at agglutination. Now, we have agglutination. That's the one that was before it got filtered. This was what was left over from what I poured through the filter. I mean, I just poured in 20 mils in each. All right? Wow, okay. Let me move it just a little. 6.55. Excellent. And then let's see if the filter, after that material dropped to the bottom, and I didn't stir it either. I let it settle, you know, and then I poured just the top of the liquid off, and that's what came through here. 6.32. Oh, it's going up a little, 6.40. I'll stir that just a touch. 6.5044. Okay, 6.44. Yes, these move around a little bit, but this gives you a good idea of what is it that's being filtered out. In this case, we're looking for the hydrogen, the acid part, or the base part. Sedimentation, which was this last one, and all we did is let that sit for longer. We stirred it up before we filtered it before. We just let this sit so that the particles could settle down. And I let it sit about an hour just to see if it gave more of an influence than what the lab says, which is about a half an hour. Okay, 6.6. All right, excellent. That's the pH sensor. Now, oh, and I've got the calibration that's right here. I did calibrate it right before we took the film. So let me show you that calibration process just so that you can see it. And it didn't goof up my results, but I had performed it right before filming. Let's put these into the two calibration solutions. The way that you can do this, go ahead and stop, is if you have your SparkView running, I usually just go to this little data bar, that's the live data bar, and I'll calibrate the measurement. just so you can see this process, because it is important, especially if you haven't used these for a while. It's important to sort of set the pH so it knows how to read what's expected. These are two different solutions I poured out. The blue is about a 10.0 pH unit, and this is about a 4 unit. So I'll put these into these solutions, and we'll say, oh yeah, let's do a 2-point calibration. Continue. This is the one that's supposed to be 10. Here's what the reading says it is right now in that solution. I'll set it as 10. That's what 10 means. Okay. And we'll rinse it off. And we're going to put it into this red solution, which should be around the 4.0. We'll let the values come together to a stable amount. Tip it a little bit so that it's a little deeper in the solution. Okay, and I'm going to set that. So that's calibrating the pH sensor and measuring. Obviously, you want to do that before you measure, especially if you're the first class or something, so that you get this to be measuring what's supposed to be coming out. Again, I had just performed this calibration right before filming this, so even though I did it second, my values are still, I would trust in. Okay, let me put that back on the bottom here. We'll put that in our storage area. So that was the pH sensor. Now we've finished looking at the pH of the solution, how much H plus or acid is in there, or how much hydroxide, OH minus, is in those solutions, and seeing if this filtering process can take any of those out. Okay, so we've gone from conductivity through pH. Let's take a look at how cloudy those solutions are. That, we're going to use this instrument right here called a colorimeter. Colorimeter shines white light through it, or normal colored, all colors of light. And then if the substance absorbs some of them out, it looks the color that makes it through. If some solution is red, the red light is making it through. We're looking instead is if it's cloudy. In other words, if the light itself, not caring if it's red or yellow or green, if the light of all of those come through gets somehow blocked out. So what they're going to use is a sort of standard solution. We're going to tell it this is a known amount of cloudiness. This is sort of a white, milky substance. I'm going to pull this and put this right here. Actually, it's better to probably put it right here. You can see that there's a little bit of cloudiness to it. We know what that cloudiness is. It's called 100 units. And I'm going to calibrate this instrument. Notice on the last one when you did pH, I calibrated after, even though I had taken care of that. Let's take a look at our turbidity. By clicking here, I can calibrate this measurement. And you notice first, we're using the turbidity sensor. Second, the measurement we're going to be looking for is called the turbidity, and it's given in NTUs. All right. There we're going to put a blank in. So I'm going to, but I have to put the blank in. So I've taken one of these cuvettes, and all I've done is I've put a little bit of water into this from the sink. I just put it in from my water bottle. We're assuming that has no turbidity. I'm going to recalibrate that, and that's going to be stored instead of that time when there was nothing in there. Okay. Now the last step is to put in the solution that we know how cloudy it is. This gets sent to you with this instrument, so you can put that solution into a cuvette and say, that's what 100 looks like of this cloudiness factor. And now we're done. Fantastic. Now, what we're going to do is we're going to use these cuvettes to put some of our solution in and see how cloudy they are. Let's start with the unfiltered. I stirred up the solution and just poured it straight into the funnel, or into the filter. The light shines a little bit lower, so I'm at least 2/3, half to 2/3 filled will be enough. And like I said, the light comes in through more towards the bottom. I'm going to put that into here and close the top. And in the bottom corner, you can see the turbidity is reading, but I'm going to start so you can see what this value is. It's about 672 for the unfiltered water that was poured right through, untreated water that was poured right through the filter. So that's this first one. Turbidity is 672.2. Awesome. Now I'm going to use the water that comes from here before it's filtered. Agglutination has happened, but not filtering. Be careful not to end up pouring any of the, as little as possible. Most of this stuff that's in here is more like wood or the soil particles, it floats to the top. Okay, but most of that's clear enough, so let's put this in here. This is agglutination, but it was not filtered. Oh, that looks pretty good. So this is just the agglutination process. Is 102. Oh, it's even a little lower. Let's say 91.7. Nope, I've got to put it in the right pile though. 91.7. Okay, now we're going to test that which has been filtered. I'm going to use the same cuvette because, actually, no, I'm going to use this one. It had the water in it before. Okay, then we're going to put in this after the pool clarifier went in and we filtered it. Okay, it's still measuring. And that's a little lower than just 60.8. A little lower than the unfiltered, but added clarifier to it. Now we're going to go to the activated charcoal. I'm going to put this into our cuvette. So it poured through the filter that had the activated charcoal impregnated into the side. Okay, that's a little higher, isn't it? Activated charcoal. Oh, I put this in the wrong slot. Let's get the correct space there. Let's put the activated charcoal filtration as 336. The last one is after letting it sit for, like I say, an hour. You can see, here's the original one. You can see the top little quarter of it is starting to clear up. And if I let it sit overnight, it would clear up quite a bit. But still keeps that sort of brownish look to it. So this was allowing sediment to fall down, and then we filtered just what was on the top. And the cloudiness for this is 223. Okay. Put these behind each of this. The lightest one was the agglutination. The next lightest one was the charcoal. No, this was the parent to the agglutination. Here's the activated charcoal, and this one was lower, is there. All right. The odor, I can still smell the individual beakers because there's enough water in there. Now, one of the things I did put in the master is the master solution was a little bit of coffee, but you might have leaves or other things that leach in there. And so this one still smells. This one is about the same. That's just agglutination. This one's just filtered. Here we used activated charcoal. It's faint. So if anything, it's probably a little less. And then this one just sat and sedimented. And that one's very strong. So these guys that didn't do chemical, the charcoal is probably the least of these, but they all still smell like coffee. So I'll just put those in. Coffee, smell, coffee, smell. Coffee. And the only difference was that the charcoal had a faint coffee smell. So I'll just mention that. The last thing is, what do these look like? And this is a good place to take a look. So let me pull these out of the way so you can get a good front shot. You're still in that same order. So this one is untreated, and that is brown, cloudy solution. Brown, cloudy solution. This one's a clear, almost yellow, and that is the agglutination. So make sure I put that one yellow. And pretty clear. It was quite a bit less solution. This one was the activated charcoal. This is, it's even a little darker brown than these two on the sides. So I'll even go with a, looks like it got a little darker brown. And the last one's, this is agglutination, but not filtered. Okay, yellow clear. Well, maybe I'll say yellow cloudy because it did have more turbidity than the, and I'm flipping those. So this one should be yellow clear and the previous one should be yellow cloudy. Finally, sedimentation is just the brown cloudy. Looks much like that very first one. All right, so now we've taken all the data. You should be able to go in there and think about what that means in terms of interpretation. We'll come back and talk about the challenge and what we should do to interpret these results and the analysis in just a second. Great work on following through to see what has changed when you used each of these types of filtration methods. And each of those is used in processing of water, whether it's filtering it, letting things settle, adding something that can pull the other things out of it, agglutination, and others might be to pour through something like activated charcoal or filters that are particular for smell particles that have an odor, for instance. Let's take a look at what we've just done. If you, in the sheet that we'll post up right now, look at those. I went back to the original material, and the original pH, for instance, was 6.14, a little lower than what I would consider normal pH of 7. All the materials we looked at had been filtered, had a little higher values of pH. What can that mean? Well, a lot of paper is made from a process that adds a little bit of materials to it. So it may change the pH, or in this case, what was left in the bottle is a little lower than all the rest, so that has a little more acid to it. That could have come from even the last little bit of stirring that I had done when we kept using this. Because at one point, I stirred those two solutions that we checked the calibration for the pH sensor. So if 6.14 is truly the reading of the water and the others are 6.5, 6.9, which are normal, I have a tendency to think maybe I put something in that water, and you'll have to check your samples when you do the lab to see if that's the case. Next, let's go to conductivity. Conductivity in this untreated, unfiltered water was about 1100. Okay. If you look in the examples that we took, almost all of them had a little higher values of that, so they may have picked up a little of something in those papers, maybe something that's dissolved in the paper itself. Like I said, some papers are usually treated with light acids when they're being processed from pulp into this, and so they may retain a touch of their properties. We saw that wasn't the case in the pH, but there may be something that was a little salty, some kind of a treatment that is in there. It picked up a little saltiness, or that's just the variation that's in the sensor. It's only within 25 to 35 values of each other. But we didn't see much change. Why? Because these particles are dissolved. They're dissolved and they're not just suspended. So dissolved things make it through filters. Now, the turbidity is getting out larger particles. Molecules that go into solution or surrounded by water are molecule by molecule. The bigger parts that make turbidity are actual large particles that have maybe tens of thousands of atoms or molecules large. And here we see is what takes out these the best. The value of the turbidity in the sensor was well over 600, and we saw that in almost all the filtrations except for the very first one where we poured that same solution through just the paper towel, that paper towel didn't get tons of that material out. As a matter of fact, it was very similar in value to what the untreated would have been. Now, when I hold these next to each other, I would say these did get some of the particles out because it looks like it's filtered some, but there's still quite a bit of milkiness to that solution. Again, if we move to the next column, you'll see that the odor in there is always of coffee. And the only one that didn't, it still had some smell of coffee. Again, we put that in to make it more smellable, but you would know if your water had some smell to it. That may have come out as the one that had a little lighter smell, and that was the activated charcoal. Charcoal has a chemical attraction, so it may be able to take some of that smell out. Maybe not all, but some. And that's why it's used in a lot of filters, like for fish tanks. So it's the only one that had the faintest smell. It still smelled of coffee. It didn't get it all. Maybe a slower process of exposing the two together would help, or a larger column of charcoal, for instance, might do the job. And finally, which one was able to take most of at least the visible particles out? And in this case, it looks like, if we're looking at this, the one that was agglutinated. It made a fine structure when we poured that pool chemical in there. That fine structure slowly settled down in about a half an hour. And with it, that, because it was part of a settling, but it helped to force the settling, it looks like it cleared the water up the most. Now, your job, after taking a look through your analysis, is say, how could you maybe put 2 or 3 of these together, or try something that hasn't been tried? Maybe you want to use sand. Maybe you want to put in some other kind of fiber, leaf pack or something like that. You'll always see that there's some trade-off between putting more layers in and how clean it gets to how much time it takes to go through there. But make those observations and run those same tests on a filter of your own design and see if you can't get these to even beat our best example, which was the agglutination or the pool clarifier. With that, we wish you the best of luck with your labs and turning these in, and we're excited for you to come up with your own filtering process. Appreciate your city because they do a great job of getting your water clean, and you can test that out with your own filtration system on your own.